What I thought I'd do is put together some explanation for a question that you did in the textbook, and that was question 7 from chapter 9 review. The question gave you some electrolytes and the electrodes, and you had to write down what the reaction was at the cathode and the anode. So the first question is, this PowerPoint works. Next, there we go. Okay, so the first one we had, the electrolyte was molten potassium iodide and the electrodes were platinum. Now, quite a few of you were wondering where you start with these questions. So the very first thing you need to do is be looking at what the electrolyte is and what the electrodes are, and start thinking about what species is present in this reaction, in this electrolytic cell. So I've got molten potassium iodide. So what that means is it's potassium iodide that is now in liquid form. So the ions have dissociated. So I've got a cation, my potassium plus, and my iodide negative anion. So those are both in liquid form. So if I think of an electrolytic cell, for this question, I didn't need to use my electrochemical series because there's only 2 species present, so that's where the reactions will be occurring. So if I think of my potassium cations, they're going to be attracted to my negative cathode, okay, because they're positive and my cathode is negative. Likewise, with my anion, it's going to be attracted to my anode. Once I've worked that out, I can write down what the equations that are going to be at the cathode and what's going to occur at the anode. So at my cathode, in a galvanic cell and an electrolytic cell, it's always reduction that occurs, and at the anode, it's always oxidation that occurs. So then I can go ahead and write my 2 equations. Okay, so I've got my potassium here, which is being reduced, it's gaining an electron, and I've got my iodine here, which is being oxidized, it's losing an electron. Okay, example B. We've got a copper 2 sulfate solution with a platinum electrode. So it's really important that you look at what the electrode is. This is a platinum electrode, which means it's inert. It's not going to take part in the reaction. So the first step, when I come across a question like this, is I write down what species are present. Okay, so I've got a platinum electrode, so I don't need to write that down because it's not going to take part in the reaction. I've got copper 2 sulfate solution. So what that tells me is it's a solution, so it's aqueous. And if we remember from last year, an ionic compound in solution will ionize, okay, into its individual components. So we've got, if we look at this, we've got copper 2 plus, and we've got our sulfate anion. That sulfate is just a spectator ion. If you're unsure, you can always have a look at your electrochemical series and you won't find sulfate on there. It's not going to take part. So my species that are present are copper 2 plus and water, because it's a solution. Okay, so this solution here is made up of copper 2, sulfate and water, but I don't need to worry about the sulfate. So once I've identified the species present, I get out my electrochemical series. Okay, so I get out my data book and I'm going to circle the species that are present. So I need to go through here and I've got a water liquid up here on the right. I'm looking for a copper 2 plus aqueous. It's really important that you're looking at the states. And I've got another water liquid down here. Okay, so I've circled all of those ones that I could find. Now, if we remember from our electrochemical series, as we're going up, they become stronger oxidizing agents, so more likely to undergo reduction. As we go down, they become stronger reducing agents, so more likely to undergo oxidation. So the reaction in an electrolytic cell is non-spontaneous. So it will occur between strongest oxidizing agent, so in this case, our copper, and our stronger reducing agent. Okay, so that's our only reducing agent. So the reaction will occur that way, down, so just like a Z. Okay, so those will tell me what my reactions are. Okay, so then I can type it up. So I know that my water is my stronger reducing agent. It's undergoing oxidation. Okay, because, pardon me, you've got your liquid over here to the right, so the reaction has to go to the left. Okay, so this is undergoing oxidation. At the cathode, I've got my copper 2 plus aqueous. This reaction, it's undergoing reduction, so I write that down as the cathode. Okay, experiment C. Again, the first thing I need to do is write down what species are present. So this time I've got a potassium bromide solution and a copper electrode. So this time my electrode will be involved in the reaction. So remember that this is a solution, so I can take apart my cation and my anion, okay, because it will ionize into its separate components, and we've also got the water present because it's aqueous solution. So I've got my potassium ion, my bromide, my water, and the electrode is copper solid. Okay, so I've highlighted all the species present. Then I'm going to do exactly the same as what I've done in question 2 or B. I'm going to highlight all these species. Okay, so I'm going to go along and look for all of them. I've just written that there. So I've found the water. Okay. So that's all my species. Okay, so I've got water, I've got my bromide ion, I've got my copper, and I've got my potassium ion. Then I need to go through and find what is the strongest reducing agent and which one is the stronger oxidizing agent. So the strongest reducing agent is going to be my copper solid. My stronger oxidizing agent is going to be this water here. Okay, so my reaction is going to be between these two species. Okay, so then I need to work out what's the reaction that's going to occur at the anode and what's going to occur at the cathode. So this reaction here, this is my stronger reducing agent. This reaction is going to occur in this direction. This is going to occur in this direction. So for my copper solid, it is going to be oxidized, and this will occur at the anode. My water will be reduced, and this will occur at the cathode. Okay, and they're my two equations. Okay, experiment D. Okay, we've got a mixture of copper 2 nitrate and nickel 2 nitrate solutions with a carbon electrode. So this time, again, we've got an inert electrode, so carbon isn't going to take place in the reaction. I've got copper, so copper 2 plus, nickel, and water. Again, the nitrate is just a spectator ion. It's not going to be involved in the reaction. Okay, so if we look back at our previous question before when we had potassium bromide, okay, I could find both potassium and bromide on my electrochemical series. Whereas here, if I looked at my electrochemical series, I'm not going to find nitrate. Okay, it's not going to be involved in the reaction. It's just a spectator ion. So once I've identified my species, I can get out my electrochemical series and start highlighting. So I've got copper 2 plus aqueous, I've got water, and nickel 2 plus aqueous. Okay, and the other water. Again, the reaction is just going to occur between the stronger oxidizing agent and the stronger reducing agent. My water will be oxidized as it's the stronger reducing agent, and my copper 2 plus aqueous will be reduced as it is the stronger oxidizing agent. So this will be oxidized at my anode, and my copper 2 plus will be reduced at my cathode. Okay. Very last question. Lithium fluoride solution with a platinum electrode. So this time I've got an inert electrode again. I've got a lithium fluoride solution, which will ionize, and I've got my lithium plus ion, my fluoride ion, and it's a solution, so I've got water. So once again, I get out my electrochemical series. I highlight the species that are present. Okay, 25. Okay, and then exactly the same as before, I need to highlight what my stronger reducing agent is and what my stronger oxidizing agent is. Okay, my stronger reducing agent will undergo oxidation. My stronger oxidizing agent will undergo reduction. This reaction here will occur at the cathode, and this reaction here will occur at the anode. Okay, and that's how we do some of the electrolysis questions for question 7 of chapter 9.